All right, new chapter. Section 11.1 is measures of central tendency and dispersion. What we're going to be talking about in this chapter is statistics. We did probability last chapter. This chapter is statistics. Statistics are numbers that compare sets of data. So we're going to take the information, those numbers that we got from the probabilities, and we're going to compare them to each other. All right, you've done this. You've done these first few, I'm sure, and so we'll zip through them quick. The measures of central tendency simply mean the middle of the set of data, and there's three different ways, and I'm sure you've done all three of these ways already. Three different ways, different types of central tendency that we might look at. One is the mean, and you're going to see this might be new. You're going to see this indicated by an X bar. An X with a bar over it, and that just means the mean of a set of data. And that just means the average. And so if you'll remember, that means take the total of all the numbers and then divide by the number of numbers. All right? And we'll do one in a second just in case you've forgotten. But the mean is just the average. Add them all up, divide by the number of numbers. The median is the middle. Now what's important with this, and you might need to add a little extra note, make sure that the median is the middle of all of your numbers as long as those numbers are in numerical order. So if you need to check to make sure that your numbers are in numerical order, and once they are, you just find the middle, and there's your median. All right. The mode is the number that appears most often. So I remember it. The mean is pretty mean because it makes you do a lot of work. You add them all up, divide by the number of numbers. The median is like the middle of the road is the median. So it's just right there in the center. And then the mode, the way I remember it is the mode is the most. And now be careful, it's not the biggest number. The mode is the most, the one that occurs the most often. Let's do some of these. All right, so we've got a couple of different races that happened on a couple of different weekends. And these are the number of minutes that it took the different runners to run these races. So if I want to figure the mean, median, and mode of race A and then race B, so the mean is simply going to be add them all up and divide by the number of numbers. So the mean of this group of numbers is, if you'll take your calculator, pause for a minute and add them up, 4 plus 7 plus 8 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12, you should see that the total was, did you get 78? And then you're going to divide by the number of numbers. There are 9 numbers here, so you're going to take 78 divided by 9. Do that in your calculator, and you should get 8.7. All right? Easy enough. If not, slow down and back up and look at it again. We're going to keep going because I think you know these already. The median is the middle. And so in this case, since there's 9 numbers, you're going to simply go to the middle number. 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. So 9 is the median. One thing I didn't put on your notes that you may need to remember, and I was realizing that we've got nine numbers in both of these sets, so I don't get to show this to you. The middle number, excuse me, if there's an even number in your set, if there's an even number of numbers, then the middle number is 2 numbers. So what you'll do then is take the 2 numbers that are in the middle and take the mean of those 2. So like in this case, if there was another number here and the 8 and the 9 were in the middle, you would add 8 and 9 together, divide by 2, and 8.5 would be your median. Okay, that was a little aside. Not even an extra charge. Okay, the mode is the one that occurs most often, and the one that occurs most often, oh, here's something that I didn't mention. You can have more than one mode, or you could have no mode at all. If all of these numbers were different, there would be no mode. There's no number that is more than the others. And in this case, the 8 appears twice and the 9 appears twice. So the mode is 8 and 9. There are two modes in this group, 8 and 9. All right. Real quick, pause and do the mean, median, and mode of race B. Pause. Okay, unpause. Did you do it? I hope you did. Here we go. I'll just tell you that you should have found the mean to be 7.7. The median you should have found to be 8. And the mode would also be 8 because it appears 3 times. Okay, moving right along. The measures of dispersion. So that was measures of central tendency, finding the middle. in a couple of different, in three different ways, three different types of the middle. Measures of dispersion show us how spread out is the data that we have. How far from the middle did we go? So there are two different ways that we're going to look at that. One is the range, and you've probably done this already also. The range of a set of data is simply the largest number minus the smallest number. So it just tells us how far apart are the edges. All right. So to find the range of a set of data, you're just simply going to find your largest number and your smallest number and subtract. So back to our original data. So in this case, our largest, and these were already in numerical order to make life easier for you. Some of your sets of data in your homework are not going to be in order, so don't get tripped up by that. Make sure that you put those in order when you rewrite them onto your paper in order, so that you can, especially for the median and for the range. So you're going to take your largest, which is 12, minus your smallest, which is 4, and so your range is 8. And that's just 12 minus 4. And you've already probably figured it out quicker than I can. The range of this set of data is 11 minus 5, which is that 6? Yes. 5 and 6 are 11, yes. So the range is simply the largest minus the smallest. So that tells us there's 6 in between, 6 numbers in between the largest and the smallest. Okay, now I went really quick through all of those because you should have already known those. This is a little bit trickier. The standard deviation. Okay, this is the fun part. The standard deviation is a way to figure, okay, so that's, the range is from the biggest to the smallest. But, okay, inside that biggest and smallest, how far apart are the clumps of these numbers? So here's what we're going to do. The standard deviation is represented by this little sigma sign. So sigma means standard deviation, all right? So, and I've practiced and they still look funky. So you're just gonna have to do the best you can. It's like a little zero with a tail. I don't know. So here we go. In order to find standard deviation, you will already have found the mean, at least in your homework problems you will. So you're going to use the mean in these. And what you're going to do is you're going to take each number. These are a little bit laborious, so hang with me. You're going to take the first number minus the mean, take that total and square it. And then you're going to take the second number minus the mean, take that number and square it. And then the third number minus the mean and take that number and square it, and so on and so forth. So let's do one. And I'm just realizing that I got the final answer, but I didn't get the, well, we'll just do it together. Here we go. Ready or not? All right. So what you're going to do is this. So let's find the standard deviation of the set of data from race A. So what you're going to do is this. You're going to take the first number, which is 4 minus the mean, which is 8.7, and square it, plus 7 minus 8.7, and square that, plus 8 minus 8.7, and square that, plus another 8 minus 8.7, and square that, plus 9 minus 8.7, and square that, plus another 9 minus 8.7, and square that, plus 10 minus 8.7, and square that, plus 11 minus 8.7, and square that, plus 12 minus 8.7, and square that. You're going to take that whole total and then divide it by the number of numbers, which is your 9. So all of that divided by 9. Okay? So hang with me. It's okay. You've got a calculator. And I think that I think I did all of this. Oh, yeah. Check this out. Okay. So you do it. And I've already done this. So if you're starting right now, you'll be far enough ahead of me that you can kind of do it as we go. So you're going to take 4 minus 8.7. And square that. You just use your squared button. Is going to be the easiest way to do that. And you should get 22.09. 7 minus 8.7 and square that. and you should get 2.89. And then 8 minus 8.7, and then square that, and you should get 0.49. Another of the same thing, obviously you don't have to do it again, 0.49. 9 minus 8.7, square that, you should get 0.09. You're going to have two of those. And then I'm writing too big again. Where are we? 10 minus 8.7, take that answer and square it. And that should be 1.69. And then 11 minus 8.7 and square that. And you should get 5.29. Are you still with me? Are you still doing this? And then 12 minus 8.7, square that. And you're going to get 10.89. Now, I want to back up and make sure you remember, you know that the 8.7 we got from right here, this is the mean we figured out, right? I hope you remember that. Okay, so each of these numbers came from each of these. So we took each of these, individually subtracted 8.7 from them, and squared them. That's where all of these numbers came from. Then we add it all up, divide by 9, and our answer should be, if you add all of that up, you should get 44.01. Divide by 9. Uh-oh, guess what? Guess what? On all of these I forgot to put, but it's not a big deal. It's just going to affect our final answer because all of that, it's the square root of that. So 44.09 divided by 9, and take the square root of it, and you should get 2.2. Whoo-wee! A lot of tedious work, all right? And I can't remember, I didn't have you do tons of those. So I want you to know how to do it, and I want you to know that it works, but you don't need to do 12 or 16 of them. All right, so here's the deal. I've got one more thing to cover with you. These are obviously going to take the longest amount of time, all right? But just, it's okay. Buckle down, use your calculator, get going. Now, what happens then if I have what's called an outlier? If you look, most of these numbers are fairly close, and so the center is around 8 or 9, 7 or 8 in these. What happens if we have what's called an outlier? An outlier is a number that is significantly larger or smaller than the numbers in your group of data. Okay, so you may want to add that to your definitions. Outlier. Number significantly larger or smaller. Oh, ha ha ha. Than the others. Okay. Here's what I want you to do. Let's do one more. And we're going to do a smaller group of numbers here. Here's what I want you to do. I've been training for a triathlon. Not me, really. Someone has been training for a triathlon, and these are the training times that they've come up with for the past 7 weeks. So what I want you to do is find the mean, median, and mode and range of these. And I'm looking at time, and I know that this is taking a long time, so let's do it real quick together. So the mean is add them all up and divide by 7. So 17 plus 20, quick, put it into your calculator while I clear a spot. Mean. Okay, did you do it? Add them all up, and you should have gotten 132. So divide by 7, which will give you roughly 18.9. That's your mean. All right. So your median, now remember you got to put them in order. So once you write these in order, oh man, I messed with you, huh? So let's put them in order. 16, 17, 18, 19, 20, 20, 22. 1, 2, 3, 4, 5, 6, 7. All right. So to find the median, we simply go to the middle. Oh, look, there's an odd number. So the median is 19. The mode is easy. See how quick this is? The mode is easy. There's one number that's doubled, so the mode is 20. And the range The range is 22 minus 16. Do it quick. 22 minus 16 is 6. And the standard deviation is trickier. All right? So the standard deviation, remember, you're going to take 16 minus 18.9 and square it. So pause real quick and do that. 16 minus 8.9 squared. 17 minus 18.9 squared. 18 minus 8.9 squared. All of those divide by 7, take the square root, and the standard deviation is 1.9. So what that means is that between each group, and we'll show you, we'll talk more about standard deviations in the next section, okay? And then I'll show you where it means that that's the cluster is actually in this case pretty close. Okay, then what I want you to do now is, so now that's what happened in the first 7 weeks. And now I had another really good, wow. Somehow I had a time of 3. Something tells me you took a bus or something. I don't know how you did a triathlon in 3 minutes. But so if we had an outlier of 3, something weird happened that day. What happens if we add that number of 3 into these numbers? These are all kind of clustered and they're all together. What happens to this mean, median, and mode and range and standard deviation if we add in that 3? So go ahead and do that. Start with your mean, and you already added the 132, so just add 3 more to it. Mean. The new mean is going to be what? 132 plus 3 is 135. And now be careful, because now you're going to divide by 8, not 7. So 130 divided by 5 divided by 8 is about 16.9. Okay? And then the median now is going to be, now the median, because this outlier of 3 is going to go to this front. The median now, there's a 3. Let's add it on to the beginning here. So now there's a 3. And then when you go to the middle, it's halfway between 18 and 19, so 18.5. And I'm standing right in front of it. It's kind of hard to know where to dance here. All right. So the median is 18.5. The mode, the new mode is still 20 because there's not 2 3s. The range, now the range is the 22 minus 3. So the 22 minus 3, the range is now 19. And the standard deviation is, now what you're going to do with this is take the number that you already got, all right? Take the number that you already got, and now take 3. Actually, you know what? That won't work. It won't work. You got to start fresh because you've got a new mean now, all right? So pause real quick. Take 3 minus 16.9 squared. 16 minus 16.9 squared. And do them real quick, and then take the total and divide by 1, 2, 3, 4, 5, 6, 7, 8. Total divided by 8. And the square root. Did you do it, or did you just wait for me to do it for you? The standard deviation is, the new standard deviation is 5.2. Now, the reason we did all this is, how does an outlier affect all of these central tendencies? Now, if you'll look, the 3 central tendencies, how did it affect those, and which one did it affect the most? So we can look to see, well, the mean changed a little bit. The mean kind of slid down because our outlier is very low. All right, so it went down a little bit. The median went down not very much at all, right? Because this is just one more number. It doesn't affect the value in there of the median. And the mode doesn't change at all. So the one that is most affected is going to be the mean, because that has to be added into that whole total, and it affects the values of the value of the middle instead of the physical middle of the numbers. All right. The range, you can see the range was affected quite a bit. The range went up a lot because the range is the difference, and an outlier is going to affect the range a lot because it spreads out where are the outside edges. And the standard deviation went up quite a bit because we have to account for this outlier that's way out on the edge somewhere in the fringes. So your standard deviation and your range are going to be affected a lot by an outlier. The median will also be affected. The median and mode will be affected some, maybe not very much. All right, there we go. A lot of stuff, but not difficult. Not very many problems because they're pretty tedious. So I will see you next time.